In the restless waters of the North Sea, 45 kilometers off the coast of Belgium, a vast engineering project is taking shape. Unlike other artificial islands that the world has seen, built for tourism, real estate, or military strategy, this one has no hotels, no beachfront villas, and no casinos. Instead, its entire existence revolves around one single mission: to capture, store, and distribute renewable energy across Europe. Known as the Princess Elizabeth Energy Island, this 6-hectare marvel is being constructed at an estimated cost of around $7 to $8 billion. It is the first artificial energy island in the world and one of the most ambitious renewable infrastructure projects ever attempted. The island's purpose is straightforward in theory but monumental in practice. It will act as a hub that collects electricity from surrounding offshore wind farms and then distributes it both back to Belgium and across international energy links to neighboring nations. This project is part of a grander European vision to transform the North Sea into a renewable powerhouse capable of supplying the energy demands of hundreds of millions of people. Yet, as with many projects of unprecedented scale, the challenges are immense. Costs have spiraled, technological bottlenecks have slowed progress, and political pressures are threatening the viability of the entire plan. To understand why Belgium is investing so heavily in this man-made island, it is necessary to examine both the nation's existing role in offshore wind and Europe's broader ambitions to achieve energy independence in an uncertain geopolitical climate. Why Belgium needs an energy island. Belgium may not be the first country people think of when it comes to global leadership in renewable energy, but this small nation has already proven itself a major player in offshore wind power. With 8 functioning offshore wind farms, Belgium ranks 7th worldwide in installed offshore capacity, a remarkable achievement for a country with a coastline of only 65 kilometers. Offshore wind already contributes significantly to Belgium's energy mix, supplying millions of households with clean electricity. The origins of this energy island can be traced back to 2016, when Belgium joined 8 other North Sea countries in an agreement to jointly develop offshore wind resources. The collective vision, later formalized into what became known as the North Sea Wind Power Hub, was to build a connected grid of offshore wind farms and transmission hubs. This hub-and-spoke model would allow countries to share energy seamlessly, sending surplus electricity from regions with strong winds to those experiencing calm weather. The initiative gained further significance in 2022 when Russia's invasion of Ukraine plunged Europe into an energy crisis. With natural gas supplies from Russia severely curtailed, European leaders realized the urgent need to scale up renewable energy sources and reduce dependence on fossil fuels imported from geopolitically unstable regions. At the 2023 North Sea Summit, Belgium and its partners committed to quadrupling offshore wind capacity by 2030 and increasing it tenfold by 2050. Such an enormous expansion would require thousands of new turbines, and just as importantly, efficient ways to transmit and balance all that electricity across borders. The energy island is Belgium's solution to this challenge, serving as the collection and conversion hub for 3 massive new wind farms located in the Princess Elizabeth Zone. Without such a hub, each wind farm would require its own costly cable connection to shore. By consolidating this infrastructure on a single artificial island, Belgium not only reduces costs, but also creates a strategic node for international energy exchange. Inside Princess Elizabeth Energy Island, the functionality of the island revolves around efficiency and connectivity. The Princess Elizabeth Zone will eventually host hundreds of new turbines generating roughly 3.5 gigawatts of electricity, more than enough to power several million households. Instead of routing all that electricity individually, the island will centralize it and send it back to mainland Belgium via a single high-capacity transmission route. What makes this design especially innovative is the dual capacity of the island to handle both alternating current and direct current. Alternating current, or AC, is the type of electricity most commonly used in homes and businesses. It works well over short distances, but becomes inefficient when transmitted across hundreds of kilometers. Direct current, or DC, on the other hand, loses far less energy during long-distance transmission, making it the ideal format for sending power across borders. By converting AC electricity generated offshore into DC before transmitting it inland or abroad, the island ensures that far less power is lost along the way. This dual capability is crucial because the island is not just designed for Belgium, but for Europe as a whole. Two major undersea interconnectors are already in the planning stages, one called Nautilus, which will connect the Belgian island to a British hub, and another named Triton Link, which will connect it to Denmark's future hub. These cables will allow energy to flow in multiple directions, balancing supply and demand across borders. In practice, this means if Belgium produces excess electricity during a particularly windy week, that power can be exported to Britain or Denmark. Conversely, when winds die down in the North Sea, Belgium could import renewable power from its neighbors. This kind of transnational sharing is essential for Europe's ambitious goal of creating a resilient, interconnected renewable energy grid. By 2050, planners envision the North Sea producing around 300 gigawatts of offshore wind energy, enough to power about 300 million homes, which is more than the total number of households in Europe today. How to build an island from scratch. Constructing an energy island in the middle of the North Sea is no trivial task. Belgium has no natural islands along its coast, so engineers had no choice but to design one entirely from scratch. The process begins with the creation of massive hollow concrete structures called caissons. Each caisson is built onshore and then floated into position before being sunk onto the seabed, which lies 18 meters beneath the water's surface. The scale of these caissons is astounding. Each one measures nearly 60 meters in length, up to 32 meters in height, and weighs around 22,000 tons. Building just one caisson requires a workforce of 800 people and takes 3 months of non-stop labor. Special sulfate-resistant cement is used to ensure the structures can withstand the corrosive marine environment for decades to come. Once positioned, the caissons are filled with sand and rubble, anchoring them securely to the seabed. A total of 23 caissons will eventually form the outer wall of the island, enclosing an area that will then be filled with 3 million cubic meters of sand. The sand is compacted using a technique known as vibroflotation, where a probe injects water and vibrates the particles until the entire foundation is dense and stable. After the perimeter is complete, workers will cover the surface with concrete to provide a durable platform for the electrical infrastructure. The final island will measure 6 hectares, roughly the size of 9 football fields. A small harbor will allow ships to dock, and a helipad will provide quick access for engineers and maintenance crews. Interestingly, when human staff are not present, the island will be patrolled and inspected by robotic dogs, 4-legged machines equipped with cameras and sensors. These robots, already tested on offshore platforms, will roam the island, checking for damage or faults, and transmitting data back to operators onshore. Environmental considerations. Constructing a man-made island in a delicate marine ecosystem inevitably raises environmental concerns. To mitigate harm and even create potential benefits, Belgian engineers have incorporated what they call a nature-inclusive design. One major step has been the use of ultra-low carbon cement, which reduces the project's carbon footprint by 40% compared to traditional concrete. In addition, the outer walls of the island will include 3 specially designed ledges meant to attract colonies of black-legged kittiwakes, a species of seabird common to the region. Artificial reefs are being installed around the island's corners, with irregular surfaces intended to encourage the growth of shellfish and other marine life. Raised oyster beds are also planned, with the hope that these ecosystems will not only boost biodiversity, but also help protect the island's foundation by reducing erosion. Environmental groups remain cautious, pointing out that the long-term impact on marine life and fisheries is still unknown. They worry that the dredging, construction noise, and altered currents could disrupt sensitive ecosystems. Nevertheless, many policymakers argue that the risks are outweighed by the benefits of reducing Europe's dependence on fossil fuels. The project represents a calculated gamble that nature will adapt and perhaps even thrive around the new island. The escalating costs and looming crisis. If the technical challenges are daunting, the financial hurdles are proving even greater. When the Princess Elizabeth Energy Island was first proposed in 2021, the estimated cost was about 2.5 billion euros. By 2025, the figure had ballooned to more than 8 billion. Inflation has contributed to the increase, but the real culprit lies in the global shortage of direct current conversion equipment. Only a handful of companies worldwide manufacture the specialized hardware required for offshore DC substations, and with dozens of countries racing to expand their renewable energy capacity, demand has far outstripped supply. Prices have soared, and delivery timelines have stretched out for years. The skyrocketing costs have rattled potential investors and energy buyers. In January 2025, a coalition of energy consumers urged Belgium to pause construction and redesign the project to make it more affordable. Just a few months later, in June 2025, the project's most crucial component, the DC infrastructure, was officially cancelled. This decision does not stop the basic island construction, which continues as planned, but it does undermine the island's ability to function as a multinational energy hub. Without DC capacity, the island can only serve a limited role in Belgium's domestic energy system. The original target was to have the island operational by 2030, but even before the cancellations, that timeline was considered overly optimistic. The latest projections suggest a launch in 2032 at the earliest, and only if financing and equipment bottlenecks can be resolved. Otherwise, the island could risk becoming an unfinished monument to Europe's overambition. Europe's wider offshore wind struggles. Belgium is not alone in facing these formidable headwinds. Across the continent, even countries celebrated for their green leadership are grappling with mounting economic and logistical challenges. In Denmark, for example, what was once heralded as a pioneering energy island in the North Sea has been postponed to 2036, pushed back by at least 3 years due to soaring costs and difficulties securing financing. Denmark had hoped for a 2033 completion, but the project, estimated at nearly 200 billion Danish crowns, around $30 billion, has been delayed after Belgium stepped back and efforts to bring in German co-funding faltered. Beyond Denmark, the United Kingdom has also seen major disruptions. The energy giant Ørsted has halted its Hornsea 4 project, a massive 2.4 gigawatt offshore wind farm, citing surging supply chain costs, operational risks, and macroeconomic pressures. The cancellation is expected to cost between £399 million and £513 million in contract break fees. This shockwaves through the UK's clean energy plans, undermining its effort to triple offshore wind capacity by 2030. Meanwhile, Germany and other EU states are wrestling with their own bottlenecks, supply chain shortages, especially in cables, turbines, and substations, rising interest rates making financing more costly, and growing local resistance to offshore developments. A McKinsey report noted that offshore wind project costs had increased by 40 to 60%, leading to a relatively high density of project cancellations in recent years. Despite these setbacks, Europe's climate ambitions remain resolute. The EU has reaffirmed its long-term commitment to offshore energy, targeting 60 gigawatt by 2030 and 300 gigawatt by 2050 across the continent's seas. But the path ahead has become a high-wire act, balancing ambition with affordability, resilience with realism. Offshore wind still represents one of the continent's most promising routes toward decarbonization, yet delivering on that promise now requires fierce political will, supply chain innovation, and financial resilience. Will the dream survive? Despite these mounting headwinds, the vision of the Princess Elizabeth Energy Island remains a compelling emblem of European renewable ambition. If completed as originally designed, with full DC conversion infrastructure and international interconnectors, it would stand as the world's first artificial energy hub. It could serve as a powerful proof of concept that such infrastructure can scale to serve a continent, cementing Europe's green future. Yet the project's viability hangs in the balance. The unprecedented surge in costs, caused by inflation, scarce specialized equipment, and soaring demand, has already shut down the island's crucial DC component. Without it, the island may be relegated to a domestic collector rather than a pan-European energy node. Several scenarios now loom, one where Belgian and European partners manage to renegotiate contracts, secure additional funding, and restart the DC build, possibly with newer, more cost-efficient technology. another where the project is scaled down, serving only domestic Belgian needs, and a darker prospect where it becomes emblematic of overreach, a symbolic failure rather than a flagship of clean energy progress. The stakes could not be higher. The EU's Green Deal, its REPower EU agenda, and 2050 net zero targets all rely heavily on offshore wind as a central pillar. Failures like Hornsea 4 and Denmark's island delay are early warning signs that capacity targets may slip and public trust could erode if green megaprojects fail to deliver. Yet there remains hope. Global wind installations soared to 117 gigawatt in 2024, a new record, indicating of continued investor and technological momentum. Innovations in financing, modular construction, and international cooperation could still salvage the project's original potential, reinforcing Europe's leadership in renewables. In essence, the fate of Princess Elizabeth Island could become a defining chapter in Europe's energy story. Whether it transforms into a landmark achievement or a cautionary footnote may determine whether the continent's offshore wind revolution can truly scale. An island of hope and uncertainty. Belgium's Princess Elizabeth Energy Island stands today as both a powerful symbol of Europe's determination to leave fossil fuels behind and a sobering reminder of how complex and fragile such transitions can be. On one hand, the scale and audacity of the engineering inspire awe. The colossal concrete chasms lowered onto the seabed, the millions of cubic meters of sand compacted into a man-made foundation, and the futuristic vision of robotic dogs patrolling the island when humans are absent. This is not just construction. It is infrastructure built with the ambition of redefining how an entire continent generates and shares its energy. The environmental design of the island also reveals a serious effort to integrate human progress with ecological responsibility. From oyster beds and artificial reefs intended to foster marine biodiversity to sea wall ledges that encourage the nesting of black-legged kittiwakes, the island attempts to blur the line between human-made structures and natural habitats. If successful, it could set a precedent for how large-scale industrial projects coexist with fragile ecosystems, offering lessons for future offshore energy hubs across the globe. Yet the obstacles are undeniable and mounting. Costs have more than tripled since the project's inception, surging from 2.5 billion euros in 2021 to over 8 billion euros by 2025. The global shortage of high-voltage direct current equipment has crippled timelines and forced cancellations, highlighting just how dependent Europe's green transition is on a narrow set of suppliers. These bottlenecks expose vulnerabilities that go far beyond Belgium, threatening the pace of the entire offshore wind sector across Europe. The project's future now hinges not only on the ingenuity of engineers, but also on the resolve of politicians and investors. Will the European Union provide stronger collective funding mechanisms? Can manufacturers scale up production fast enough to bring down costs? And perhaps most crucially, will public opinion remain supportive as the price tag continues to rise? These are the questions that will determine whether Princess Elizabeth Energy Island becomes a continental linchpin or an expensive monument to ambition outpacing reality. What makes the stakes so high is that the island is more than a Belgian project. It is a European one. It sits at the center of the EU's strategy to create a North Sea supergrid that could generate 300 gigawatts of electricity by 2050, enough to power more than 300 million homes. If the island succeeds, it will demonstrate that cross-border renewable cooperation is not only possible, but also scalable to meet the needs of an entire continent. If it fails, however, it could cast doubt on whether such massive transnational projects can ever overcome the economic, logistical, and political barriers that confront them. For now, the project pushes forward at a steady pace, one caisson at a time, even as the uncertainty around its final form grows. Engineers continue their work against the backdrop of mounting debates in parliaments, boardrooms, and international summits. The world watches closely, aware that the lessons from Belgium's experiment will reverberate far beyond the North Sea. The fate of Princess Elizabeth Energy Island, and by extension, much of Europe's renewable energy ambition, hangs delicately in the balance. Whether it becomes the beating heart of a continental clean energy grid or a cautionary tale etched into the waves of the North Sea will depend on choices made in the next few years. What is certain, however, is that this bold experiment has already reshaped the conversation about what is possible in the fight against climate change. And that's the story of Belgium's $7 billion Princess Elizabeth Energy Island. What do you think? Will this project live up to its promise, or will rising costs sink the dream? Let us know your thoughts down in the comments. We'd love to hear your take. If you enjoyed this deep dive and want to see more breakdowns of the world's biggest mega builds and green energy projects, don't forget to hit that like and subscribe to the channel.